Hi friends, this is my fifth video and today I am going to teach the next part of inverse function theorem. So let's begin. First we write the theorem, whole theorem again. It is given f is a mapping from E to Rn where E is a subset of Rn and it is a C1 mapping, that is it is continuously differentiable. Second one is given that f dash A is invertible. We have to prove that there exist two open sets U and V from Rn such that f U to V is 1 1 1 2. In the first video I have proved this one, and in this video I am going to prove the second part of the proof, which is if G is inverse of f, then which is from V to U, it is also a C1 mapping. So we will prove the second one in this video. Let y belongs to B and y plus k belongs to B, where k is very small quantity. Then there exist elements x and x plus ah from U such that f of x is equal to y and f of x plus y x plus h is equal to y plus k, as the mapping is 1 1 1 2, and also its inverse G is 1 1 1 2. Now from equation 3 we know that phi x1 minus phi x2 mod is less than or equal to 1 by h mod of x1 minus x2. Please see my first video of inverse function theorem where it comes from. So we will get phi x plus x minus phi x. We have taken mod here, then it will be less than 1 by h x plus h minus x, which is equal to x, sorry, h. Now we gave this equation number 6. Also it comes from equation 5, sorry. Also from equation 3 we have phi x is equal to x plus a inverse y minus fx. This also comes from the first part of our proof. So if you didn't see my first video, so please first see my first video of inverse function theorem, then see this video. So here from equation 3 we can write phi x plus h minus phi x is equal to x plus h minus x, which is h plus an a inverse y. So phi x plus h minus phi x, it will get y minus 1, y minus y is equal to 0, and this we get from subtraction phi x minus phi x plus h. This is equal to this, because phi x is equal to y and phi f x plus h is equal to y plus k, and if you subtract it from it, then we get k, which is in negative sign. And from 6 we get, putting this in that equation, which will equal to this. This we give equation number 7. Now this will give us this can be understood that if we take h is equal to 100, and then this will become 50, so 100 minus something is less than equal to 50, so this value is equal to 50 or greater than 50, so this value is greater than or equal to 1 by mod of h. And mod of h is less than equal to 2 into a inverse k in the mod form, and which is less than equal to norm of a into mod of k. And also we know that from equation 1, 2 lambda into norm of a inverse is equal to 1, so here it will give us lambda inverse mod of k using equation 1, where it is set now. We will use a lemma which says that if omega denotes all linear operator from Rn to Rn such that all are invertible, then if A is a linear operator belongs to omega and B be a simple linear operator on Rn, then if B minus A, taking mod of it and into norm of A inverse is less than 1, then B also belongs to omega, that is B becomes also invertible. This is a lemma which we will use in the next part. Now from equation 1 and 2 it is implies that f dash x minus a, taking norm of it into norm of a inverse is less than lambda into 1 by 2 pi 2 lambda, which is equal to 1 by 2. From equation 1 it is clear that norm of a inverse is equal to 1 by 2 lambda, and from equation 2 it is given in equation 2 that norm of this one is less than lambda, using 2 and 1. So from lemma here b is equal to f dash x and a is an invertible linear operator, so b becomes, here it is less than equal to less than 1, so b where b is equal to f dash x is also invertible linear operator. So we take f dash x which is invertible, so we take inverse of f dash x is equal to t. Now since g y plus k minus gy minus t of t into k is equal to h minus tk, where g is inverse of f, so from here we can conclude that clearly g y plus k will be equal to, if we take f in the other side then it will become g, where g plus g y plus k is equal to x plus h. Similarly gy will be equal to x and gy plus k minus gy will be equal to x plus h minus x, which is equal to h. So this will be equal to h, and t minus k we write it as now. This is equal to, if we take minus t as common, then we get k, which is equal to f of x minus f of x. Similarly from here f of x plus h minus f of x is equal to y plus k minus y, which is equal to k. So k is equal to fx plus y, fx plus h minus fx, minus f dash x into h, where f dash x is inverse of t, so we can take t inverse into t is 1, so minus into minus is plus, so h plus h, here plus h. And if you take mod both side and dividing by mod of k, then this will become mod less than equal to norm of t dividing both sides by mod of k. So now if we divide here from mod h, and so we have to multiply by mod h. Now we write the last equation again here. Into so from equation from equation from equation this one, if we take this one is star, then h by k is equal to 1 by lambda. That is h by k is equal to lambda, then h by k is equal to lambda. So this will equal to mod of norm of t into 1 by lambda, then 1 by lambda, and that is using this. Clearly, if you take k tends to 0, then the RHS becomes 0 as t as tends to 0, then f dash x is a differentiation of f, so RHS will also become 0. So we can conclude that in the left side t becomes, as this becomes 0, then t becomes different derivative of the function g. So if k tends to 0, then RHS becomes 0, then from also left side becomes 0. This implies t is a derivative of g. Now which is equal to f dash x inverse, because t is inverse of f dash x and g is equal to inverse of f. So this is right. Now g is differentiable, so it is clearly that g is continuous. Also, f dash is continuous from U to the set of all invertible linear operator from Rn to Rn, which is shown by the symbol omega here. So f dash is a continuous mapping from U to omega, and also we know that inversion of continuous function is also continuous, चूँकि inversion of continuous mapping is also continuous. This implies f dash x inverse is also continuous, and from this equation g dash y equal to t is continuous. That means g dash is continuous. That means g is a C1 mapping from V to U. That is our required proof. So next part is so that's all for this video. Thank you.